You got me? Whenever I'm ready. Okay. I'm going to time myself. Okay, thank you everyone for showing up, all 1,600 of you. Appreciate that. I know it's late in the afternoon on the last day. What we're going to do here is we're going to talk about DevOps and GitLab and how you can optimize your software delivery processes. Little bit odd being here in the IoT, I'm guessing, hall talking about this, but just like the last talk I did where I followed a guy who was talking about doing all the mechanics and the electronics and everything for the autonomous vehicles, everything's got software on it. And so we're going to talk about making DevOps happen by reinventing your software toolchain. My name is Dan Gordon. I am a technical marketer at GitLab. So I'm going to start with what GitLab is about, what we stand for. We believe that everyone can contribute. So that is in the digital world. We believe that it's not just developers that should be able to use the tools and to contribute and to innovate. It's everyone from the testers, the operations, even beyond the designers, the finance folks, legal. So as software gets more and more prevalent in the world, more and more people should be able to contribute to that software to help change the world. And when we talk to folks about that, it's over the last 10 years, it's become clear that DevOps or small iterative cycles, whatever you want to call it, lean or in some places SRE type work, where you're delivering software in small chunks, you're coordinated very closely with your infrastructure, where it's going, so that you all have the same goal of getting quality and value out to the customers at a rapid pace. And in the last 10 years, as organizations tried to make this happen, they started down a logical path. They said, we have tools, and we like those tools, and let's start putting the tools together. And pretty soon, most organizations look at this and say, yeah, I got that, and that, oh, and two of those, and one of those. And the challenge is, I see you're shaking your head, good. The challenge is then this, which is they have to be integrated together. They have to be tied together if you're going to have a seamless tool chain. And that integration takes work, and it takes maintenance because the tools all change. And oh, by the way, you've got quite a few different licenses and vendors you need to manage here. And the one that always gets me is DevOps and achieving rapid software delivery is really about breaking down silos between all the groups that deliver software. And when you start looking at separate tools, that's actually encouraging the siloization, right? So you have your ops guys using their ops tool, and you have the dev guys using the dev tool, and QA using the QA tool, and maybe there's thin lines of data between them where you're integrating, but that's not the same as full transparency to be able to empower everybody to contribute and to move things forward at a rapid pace. Some analyst studies showed that over several years of study, that organizations that have been trying to get to DevOps actually are about 80% of them are dissatisfied with the outcome that they got. And so we look at that and we said, okay, well, why? And there's a toolchain tax is what we call it. The time to acquire, we kind of just talked about this a little bit, the time to acquire different point tools, it takes an effort to actually research and validate and pick which ones you want. Time and cost to integrate the tools, we talked about that, and getting them all to talk together, keeping them talking together. The time to train all the different users, right? People are using these tools, and for every new tool you introduce, people have to learn it. Even if it's just a small section of it that they use, it's out of context of the rest of their tool. And then there's context switching. As you're actually using the software in your tool chain, if you have to move between different tools, you're context switching, and there's a known load on context switching. And then administration. There's a lot of effort and time that needs to go into administering and keeping the tools running. So we think there's a better way. At GitLab, we focus on having a single complete DevOps platform as a single application so that you can install GitLab, put your code into the repository, and it will go through the process automatically of getting built, getting tested, getting validated, packaged, delivered, secured, monitored on the far end. So this has resonated very well. We've got a lot of customers that have really understood the value of this. But the fact that we do all of those things, the goal there is to make sure out of the box you can do those things. That doesn't mean that we don't play well with the rest of the ecosystem. So, for example, we integrate with a lot of the popular tools out there like Jira and GitHub and Jenkins. We also integrate with, work well with Amazon EKS and Amazon's tools. And even more, we work with VMware. We've got, I was actually at the VMware booth in the other hall and our booth. We're showing a demo showing how we can include Cloud Health from VMware, for example, to validate that you're not yet about to deploy past your budget, for example, or Wavefront at the tail end to look at the performance of what you're just about to deploy. And so those are all things that can be pulled into the pipeline that comes out of the box with GitLab. This mic is really odd, sorry. So just a few customers. We've got hundreds of thousands of customers. A lot of them have discovered that the best way to have a wide DevOps adoption at scale is to really remove the tool aspect out of it and to focus on the culture and to focus on the work and the innovation. And so just a sampling of some customers that have discovered that with us. And then just almost last marketing slide, I promise, and we'll get into the demo. Do you have a better headset here? This is terrible. It's not sitting still, yeah. Okay. I'll just hold it. How about that? So, no, that doesn't work. Are you sure you don't want it the other way? Yeah. Okay, sorry about that, folks. I'll just hold it. So anyway, now I've given you plenty of time to stare at this. So just a few examples of some of our customers that have had some really good experiences. The European Space Agency, Goldman Sachs. So Ticketmaster improved their build and delivery process by 15x by adopting us over Jenkins. Goldman Sachs did a deployment of GitLab that went so rapidly fast that they ended up buying 2x the number of licenses that they originally planned and loved it so much and got so much value out of it that they actually turned around and invested in the company. So it goes on like that. Even Cloud Native Computing Foundation, were the supporters of Kubernetes and Core DNS and Prometheus, for example, use GitLab. And so you can see more about their stories at our website. But what I wanted to show you was really how this actually works, because the best way to actually understand it is to see it in action. And so we're going to talk about a piece that we call Auto DevOps. And that piece is really just a best practice pipeline out of the box. And when I say out of the box, I don't just mean a template and then you have to go install the tools and integrate them in. I mean all of the pieces I'm going to show you come as part of GitLab. And what it helps is to enable, as I mentioned, development, innovation to just do that, and for the rest of it to be taken care of. So let's get over to a demo. So bear with me for a second here as I deal with this. What is this? Okay. Okay, so are we still seeing me? You're still sharing? Okay. Okay, so what we're doing is we're sitting right now in GitLab. One view of it. See, there's many different things down the side that we do. This is looking at the project information. The projects are where we capture lots of information about the repository. That's where the repository, where the code sits, the issue tracking, the analytics for that project. The team members have different access and control. So that's kind of an atom of work. And you can set up hierarchy above that with groups and whatnot. I wanted, before we got into it, because we're at the AWS show here, to kind of show one of the simple one-time setups that happens and that's basically to get Kubernetes up. So a lot of people are interested in Kubernetes and what it can provide, but getting it rolling is a little bit complicated. Even if you go and get EKS, there's great stuff there. But we thought, hey, let's make it as close to one button push as we can to actually get a cluster, so people can self-serve them, their infrastructure needs. And so attaching a cluster to a project, for example, can happen by pushing a button and then filling in the cluster, the details about what you're looking for to build, and that'll get automatically attached to your code project. If you have a cluster that already exists, you can attach it that way as well. And once the cluster is attached to your project, then you can basically just code, and everything else will happen under the covers for you. Now, this is really not exactly about just that, but a lot of the magic does happen through that. The clusters can be attached at a project level, so that your team that you're working with has this available to them. It can be attached at a group level, so as you have departments and larger maybe clusters or resources you want to give up, or at an instance level. So lots of flexibility there. And once it's attached, trying to get to it here, it'll look something like this. You can have multiple ones for different environments, for example. And we automatically start pulling things like statistics from that cluster. We have apps that you can install, make it like one-click Helm install, so that you can add things like the Cert Manager and Prometheus monitoring and our own runner, Jupyter Hub, so you can do ML work or operations tracking, incident management, Knative as well if you want to do serverless. And all the data is just basically in there, and it's automatically put in, and then you're set to go. So we're going to switch to being a developer who's going to work on something now. And as a developer, I may say, I'm probably going to pop into my command line or whatever I'm used to working, but I might actually come in the morning and take a look at the work board and see, okay, what is it that I'm supposed to be working on? So we've got like a work item here, single one. This is also part of GitLab, tracking the work, having boards where people can organize their work. And so we have a simple scenario here. The app isn't really the important part. We went ahead and deployed our cool new logic, but we forgot to change the default page. Real simple thing to fix. So the issue is about discussing what's the problem. What do we need to fix? Once you figured that out, then you want to start working. You switch into a mode like where you're doing in some products, a PR, we call it an MR. And you can create that right from here. And what GitLab does is it's going to go ahead and create a branch so that you can work in. It's going to attach it to that MR. It is marked as a work in progress, so it's a draft MR. With GitLab, the flow really works that an MR isn't I'm done and I'm ready to merge. It's I'm beginning work, so let's start capturing the information and having a discussion around it. We can see that the issue is tagged, so when this MR closes and merges, that issue is going to automatically be closed and all of the resources will automatically be cleaned up. And then I can hop into my web IDE and I can start editing, coding, doing whatever I need to do. If you don't have, if you want to make a quick change, or you prefer something in the cloud, because that way it's always consistent, that's there. You can use, of course, your own ID. It's just Git, so anything you do that puts back into the branch is going to be treated as Git would. So I'm going to pull a cake out of the oven here. This is an MR that's blank. We haven't started doing anything in it yet. I'm going to switch so we don't have to watch me edit code and all that, and run the pipeline to basically the same project. I just ran it earlier and ran it all the way through. So what'll happen is when I make a code change, which will get captured when I do my commits, that'll get captured as part of the MR. And you can see here what I did was I did a few simple changes, like I made a change to trigger a vulnerability so we can see that. But then I changed the background color and I changed the greeting and I added a logo, right? So no big deal here. But what happened was when I pushed that back, GitLab automatically kicked off a pipeline. And this pipeline's where a lot of stuff is going on. So this is the default out-of-the-box pipeline. You can create whatever pipeline you want. You can take this one and add to it. You can take parts of this and add it into your pipeline. What we strive for is to be able to, right out of the box, be productive. And so this pipeline is going to look at your code. It's going to use Heroku build packs to figure out what your code is and then build it. It's going to put it into a a container. It's going to take that image and it's going to put it into our image repository, our container repository, or registry. You can use ECR, you can use any other registry, and then we're going to kick off a series of tests. Let's see if I do that. And those tests are going to do a bunch of security checks and other tests, checks. They're running in parallel. They're going to fan out. They're going to use the resources we have. We're going to do code quality check. Not sure what happened there. Using Claire, so it's going to check, code climate. So it's going to be checking, for syntax and all that. We're going to do container scanning because your application is going to go into a container, which is the application environment. We want to make sure that's secure as well. We're going to do dependency scanning, looking at all the software that you're dependent on, making sure that we understand the vulnerabilities there. License compliance management, where we're going to check the licenses of your dependencies to make sure you're not accidentally adopting an open source license that maybe doesn't align with your business practices. So you set policies and then we flag those. And I'll show you that in a minute. And then we do static application security testing. Again, reminding you this is all out of the box. So we're going to look at vulnerability signatures in your code and flag those. Unit tests from the developer. And then we're going to use our Kubernetes integration, and we're going to set up what we call as a review app, which is a full environment with your changed code per merge request for you. It's ephemeral, but it allows you to validate your changes before it goes back into a main branch or anything else. And usually this UAT kind of test or staging kind of test happens way at the end of the pipeline. A lot more valuable to have that right up front. For one, you can now check what your work is if it came out the way you wanted, but you can also send it over. This gives you a link so you can send over to your business partners, to your customers, to your UX team, your UI team, right? Your quality team. So basically, people can actually interact with your change in a temporary environment. But that also lets us do dynamic application security testing because we have a live environment, so we can look for misconfigurations that may cause vulnerabilities. And then we're also going to do performance testing because, again, we have a live app, so we're going to run site speed IO, and we're going to come back. We're going to baseline every time you do a merge. We're going to baseline where you're at as far as performance, and then we're going to check it again. So we can tell you something like, for example, that code change that you just added is going to make your user experience 10% slower, right? That's a lot of data. And so that data comes back into this merge request. And that data is now available, so I can look at... oops, I might be on the wrong one, sorry. Go away. Yeah, okay. So that data comes back here, and I can look at that information. So for example, I can see my pipeline information. I can expand and see all of the vulnerabilities that were found. And I can do more than just see them. I can actually interact with them. I can catch them. I can create an issue that's going to pull that information and make sure we're tracking it and taking care of it. I can dismiss it, in which case it's going to bubble up into other dashboards so that our team is aware and our security admins are eventually aware of what's getting by. As well, if I collapse that, I also have the report. There's no new licenses that I introduced, but I can see in my license compliance, I can see all the licenses that all of my dependencies are using. And if we have a policy set, like I have permission here to set it, then these would come up marked whether or not they're passable or not. So as a developer, as soon as I do a build, I can look and do a quick scan and see, oh, I've got licenses that I shouldn't be using. I better go change that component out. And that's a lot better to find that out right at the point of putting your changes back rather than way down the line when you think you're done. And then legal says, whoa, hold on, you can't ship that, right? So much better to do that up front. Oops, wrong thing, sorry. So I can look at all these things, and once I've validated all those and I'm good with them, and I can do approvals too. Well, we're not going to get into that because of the time. But then I may go actually, or someone who has the permissions will actually merge that code, and once that happens, we'll kick off a pipeline. And that pipeline looks almost the same because we don't know what else has changed between now and the time we're deploying. But we're going to then also do the DAS test again, and then eventually we're going to push it into staging. And that staging environment will then sit and let somebody validate it, and then we're set up to automatically allow you to incrementally roll it out now manually. It's a flip of a switch configuration change to make this so that we'll just push all the way through to deployment without the staging, without the rollout. We also have Canary that you can turn on, which will automatically track for you the difference between your Canary and your standard version. So all of this comes back down to we've deployed something, and it's sitting in our environment, and we have that tracking too, because again, we want to see from end to end. So automatically we're tracking for this project, what are the environments that we're working in, that we have. I can see the pods, where I'm deployed to, and I can get to the pod logs. So I can do troubleshooting. I can also get directly onto the container, so I can actually go look, not to make production changes, but to validate, okay, did my stuff install the way I thought it did? Maybe that's where the problem is, right? So I can look around on there. Some pretty handy stuff for doing troubleshooting. If I want to see what has been deployed in this environment over time, only 2 things here, but I have that history as well, and I can roll back to any one of those. I can go see the actual app. So those were the changes we made, and they came out okay. So this is now what's running in production. But a key piece here is that DevOps is not just about taking code and putting it out on servers. It's about understanding the life cycle and what happens when you put it in the wild and people start using it. So having that feedback loop is important so we can get those changes that are necessary back into the next development cycle, which means we need to have monitoring. And that's why Prometheus is built in. We use the open source Prometheus monitoring package from CNCF, Fame. And out of the box, you're going to get on your application, because of the Ingress controller, throughput and latency, as well as error rate, if we had some errors there. Lots of different things we don't have information for right now, but we also have the underlying infrastructure. So we know where your app is sitting, and we can tell you, okay, well, this is the behavior of the total cluster or the set of pods, in your application as you've deployed it. So we're monitoring that. If we had Canary lit up, then this is where we would be showing you data about that. And the last piece of this is if I see a spike happening, I might wonder, hey, maybe that's because of some change that I've made. So we've overlaid the deployments with the behavior in the graphs, in the monitoring metrics. So that enables me to do something like jump directly to the change that was made. So I can say, hey, if I've got a spike, maybe it was this that deployed maybe an hour before or 10 minutes before. I can see when it was done, who did it. This is the issue. Remember, we linked all that, so that takes you right back to the reason that we did this change, the details about why we did it, how we did it, the pipeline information, and the change itself. So that's pretty cool. Out of the box, end-to-end traceability and automation of your software development and delivery. That's a complete platform, a DevOps platform in a single app. And that's GitLab. So thank you.